Students, welcome to my channel Easy Learning. In today's session, I will be explaining you exponents and powers, exercise 12.1. The solution, the concept of this chapter I have already explained you in my previous video, which was part 1 of the chapter, and I request everybody to see that video before you start solving the exercise. So first question of exercise 12.1 is evaluate. So we will be using exponent laws, which I have explained to you in part 1. We will make use of those laws to solve the question. So first question, the first part of question number 1 is 3 raised to the power minus 2, right? So you see it's a negative exponent given. 3 raised to the power minus 2, when the power is in negative, when the exponent is negative, so it's a negative exponent, right? We have done the law A inverse M can be written as 1 upon a raised to the power m. It means we have to take the reciprocal. So we will be using the same law here. I can write it as 1 upon 3 square, and if you expand it, 3 square means 3 into 3, which gives you 9, and therefore it is 1 upon 9. So we have used a raised to the power minus m is equals to 1 upon a raised to the power m, and I have converted this negative exponent to a positive exponent as I have taken the reverse reciprocal of it, which gives you 1 by 9. Let's see the second part of the question, which is minus 4 raised to the power minus 2. Again, we have a negative exponent. We will make use of the same law. It is very important to write the laws with each step. So again, what we will do, we can write it as 1 upon minus 4 as it is, and since the power is in negative, it comes in the denominator as a positive power, which can be expanded as minus 4 into minus 4. When you multiply two negative numbers, you get a positive number. So your solution is 1 upon 16, right? Now let's see the third part of the question, which is 1 upon 2 raised to the power minus 5. Again, what do we have? A negative exponent. So we will make use of the same rule, can be written as 1 upon a raised to the power n. So it means you have to take the reciprocal. So what is the reciprocal of 1 upon 2? It's 2 upon 1. It means it can be 2 upon 1 raised to the power 5. So which means 2 raised to the power 5. If I multiply it 5 times, so it is 2 to the 4, 4 to the 8, 8 to the 16, and 16 to the is 32. So 32 is the solution of the given question. So these were the three parts in question number 1. Let's see question number 2, which says simplify. You have to simplify and you have to express the result. Express the result with positive exponent. So your answer you have to always convert in the positive exponent, and this I have already cleared you what do you mean by positive exponent and negative exponent. So if you are having any integer, any power, negative power with any base, it means that's a negative exponent, and if the power is positive, this exponent is positive, this indices is positive, that means it's a positive exponent. Okay, so you have to leave your answer, your result in the positive exponents. So let's see what is your part 1 of this question. It is minus 4 raised to the power 5 divided by minus 4 raised to the power 8. So children, you have to write the laws which you are using to solve the question with each step on the right hand side. Now you see here, bases are same, right? The base is minus 4 here, and in this bracket the base is minus 4, and the operation is division. So what we have done, we know that a raised to the power m divided by a raised to the power n, which means when the bases are same and the operation is division, what we can do, we can subtract the powers, we can subtract the exponents. So using this identity, using this law, what can I do? Minus 4, which is my same base, I can subtract the exponent, which is 5 minus 8. So I am getting minus 4 as it is, 5 minus 8 means minus 3. Now again the negative exponent, but you have to leave your answers in positive exponent. So again I will make use of a raised to the power minus m is equals to 1 upon a raised to the power n, which gives me minus 4 cube. So this is now positive exponent. 3 is a positive integer. It means we have converted the answer to the positive exponent. and if you want to expand it further, it will be minus 4 into minus 4 into minus 4. When you have odd number of negative sign 1, 2 and 3 in multiplication, your answer will be negative. 4 4s are 16 and 16 4s are 64. It means 1 upon minus 64 will be your answer. So basically we have used two exponent laws to solve this question. And we cannot leave our answer till here because the question says you have to write the result in the positive exponent. That is why we have done this step to write the answer in the positive exponent form. I hope this is clear. You can pause it if you want to have a look. I am moving to the second part of the question, which is 1 upon 2 cube whole square. Now 1 upon 2 cube whole square. So we have done another law, which was a raised to the power m and then whole power n, means the base is a, whose power is n, whose exponent is m, and whole power is n. We can write it as mn, right? So we'll make use of the same law here. Equals to, I can write it as 2 cube square. Now 3 into 2 gives me 2 raised to the power 6. How much is 2 raised to the power 6? This much. You will automatically start learning it. 2 to the 4, 2 to the 8, 2 to the 16, 16 to the 32, and 32 to the gives you 64. So 1 upon 64. So as you will start practicing questions, these at least the basic multiplications, basic powers you will be able to write directly. Now let's see the third part of the question, which is minus 3 raised to the power 4 into 5 by 3 raised to the power 4. Now here you have both numbers as positive exponents. What is common here? You see the powers of both the number. The exponent in both the number is same. The operation is multiplication, but the bases are different. So for this also we have done a law, which was a raised to the power m into b raised to the power m. Means when my exponents are same, m and m in both the numbers, but the bases are different, what we do? We multiply the bases and write the power as in one together. So I will use this law to solve this question. It means my bases minus 3 into 5 by 3 and power can be together, which is 4. This 3 is cancelled with this 3. I am left with minus 5 raised to the power 4. Now when you have to multiply odd even number of powers, it is basically minus 5 into minus 5 into minus 5 into minus 5. So 1 minus minus plus and plus minus minus another plus. So my answer will be positive. 5 5s are 25. 25 into 5 125, and 125 into 5 gives you 625. So this is the answer of part 3. Let's see part 4 of this question, which is 3 raised to the power minus 7 divided by 3 raised to the power minus 10, then bracket close, and then you have 3 raised to the power minus 5. Now here if you see, the bases are same but the powers are different. And as per the BODMAS rule, the first thing we will focus on the bracket. We will first solve the bracket. So let's see here, the bases are same and the operation is division. It means I can subtract the powers. So what law I can write? If the bases are same and it is in division, the first law I am using is this one. 3 as it is, now you have to subtract it. Minus 10 as it is. Let's put it in one bigger bracket and as it is. Now let's open the bracket. I am getting minus 7 and minus becomes plus, which gives you plus 10 into 3 raised to the power minus 5. Right? Now what is now? Minus 7 plus 10 gives me 3 raised to the power 3 into 3 raised to the power minus 5. Now if you see, again I am getting the same basis and the operation is in multiplication. So what identity I can use? If my bases are same and the operation is multiplication, then in that case we add powers. So what it can be? 3 raised to the power 3 plus minus 5, which gives me 3 raised to the power minus 2. So I cannot leave my answer here because as per the question we have to leave the answers in the positive exponents. So I will again use a raised to the power minus m, which can be written as this. So this becomes 1 upon 3 square, which gives me 1 upon 9. So I have used 3 laws to solve this question. Number 1, I applied this in the bracket where the bases were same. Operation was division, so we have subtracted the exponents. Now when we solve the bracket, I am getting again the same basis, but the operation now is in multiplication. So we have added the exponents. Again, we cannot leave our answer here because the question says you have to leave your answer as positive exponents. So we have used third exponent law, and I have taken 1 upon 3 square in the denominator. By expanding it, I am getting 1 upon 9. Now the last part of this question, which is fifth part, is 2 raised to the power minus 3 into minus 7 raised to the power minus 3. Again here, if you see, the exponents are same. Exponents are same and the bases are different in the multiplication. So I may use a raised to the power m, b raised to the power m. It can be a into b and powers together as m, whole power m. So let's use the law here. It gives me 2 into minus 7, right? And whole power is how much? Minus 3. Now 2 into minus 7 means minus 14 raised to the power minus 3. As per the question, we will again make use of the law a raised to the power minus m, because we have to leave the answer in the positive exponent. This gives me minus 14, but this minus 3 changes to 3 in the denominator. It means what I am doing, I have to multiply minus 14, and minus 14. So your answer will be negative since you are multiplying odd number of powers. Now 14 into 14 we know is 196, and 196 when you multiply with 14, what you will get, this gives you 4 and then another 4 here, and 14 ones are 14, plus that gives you 27. So your answer is 2744. So you have converted, again you were getting a negative exponent here, so we have converted our answer to a positive exponent as per the question requirement. With this, my question number 1 and question number 2 are done in this video. You can see my next video for question number 3. Till then, keep practicing maths. That's the only key to the success. Take care. Bye-bye everybody.